The next topic we are going to learn is the net present value calculation using Excel. Suppose you initiated a project that has a life of 4 years, and for that project you made an investment of say $50,000. And again, this could be the machinery you purchased, the people you hired, the taxes you paid, all the other expenses. So all that accounts for is 50,000 at the beginning when you initiated that project, or maybe a business you opened. And at the end of year one, yeah, you made $20,000. So let's call it as a net inflow in year one. So that's $20,000 at end of year two, 20,000 more at end of year three, 15,000, end of year four, 20,000. Yeah. So these are all the inflows for year one, two, three, four. Yeah. And again, if I sum them up for all the 4 years for the life of the project, the sum I'm getting here is $75,000. So this is the all total net inflow that I've received as a part of my project or the business I opened. And my minus my initial investment is $50,000. So again, if I yeah, let's subtract. If I check the net, yeah, positive cash flow yeah, is this $75,000, which is positive, minus the 50,000 I spent. So that gives me a net of 75 minus 50, that is $25,000. So technically on paper, that's how I will be looking at. But in business world, oftentimes this discount rate, or things like inflation rate or some other hidden taxation and so on gets ignored. And that's the reason why we should be using this some kind of rate against which we are comparing the net the inflow. So in this case, let's say our discount rate is 10% here. And yeah, we are just trying to get a real-time equivalent that accounts for the discount rate as well. Yeah, so not a straightforward these $75,000 minus 50,000 that gives me 25,000, because I mean, yeah, I can take that because it is a number, but it's not like in financial world, in budgeting work, that's not a real number. You should be accounting this discount rate, which is very important in doing all your calculations in business world. Yeah. So let's see how to utilize that formula. Yeah. So again, in Excel, this is the same formula we are using. You have to start with an equal to, enter NPV and start a formula. And first you have to enter the rate, then value one, value two, meaning, yeah, you have to select all the consecutive years. So in this case, 20,000, 20,000, 15, and 20,000 for 4 years. And then you also have to add this part, or well, technically you have to subtract this part, but again in brackets meaning it is negative. So you have to add this part, and then the equivalent you get is your calculated net present value after incorporating or after considering your discount rate as well, which is very important in business world. So let me get started over here. So 1, 2, 3, go. Equals to NPV tab, initiating a formula. First one is a rate. I'm selecting that. Then I select control and then value one, value two. So instead of selecting individually, I'm going to select all of these together. And then I'm going to close the bracket and I'm going to add the investment as well. And again, that investment amount has already been paid before you initiated the business or start of the project. So that's why I'm not utilizing this 10% within the initial investment, because it happened at say year 0 or 0.0 in your annual or timeline. So that's why I'm not applying my 10% formula or 10% rate for my investment. Yeah. And then I'm pressing enter. So eventually this is the number I'm getting after incorporating this 10% discount rate. And let me highlight it differently. And here, if I say sum of all things, I'm going to add one more thing, sum of all in net flow, meaning sum of all these year 1 to year 4 inflow equals to sum, and then I'll select all the necessary cells. So I'm getting 75,000. And technically, if I do a straightforward math, 75 minus 50, the number looks bigger, and technically it is correct. But again, you are ignoring one of the key factor, which is inflation and some other hidden factors. So for that reason, we are using inflation plus some other hidden factors. So let's count it as a 10%. And equivalent. So instead of 25,000, I'm getting 9,641. So technically, that's my real net positive inflow. Yeah, and this is the one that we'll be considering. So as of now, for the scope of this class exercise we are solving and the knowledge you have to earn, this is more than sufficient for you to understand the basics. And as you go in the future, you can take further financial class, operations class, analysis class, break-even analysis to calculate ROI, return on investment, and so on. You can learn more about it. But this is the most basic that I think you guys must be knowing as you proceed in your career. In the previous part, we learned about how to use the net present value formula and get your numbers right. Now let's learn about the next concept, which is called as XNPV. So again, in the previous formula, we saw there were some limitations where we couldn't incorporate the investment, that is your, the money you put in within the formula. So in this case, we'll be incorporating that. So this is the merit of this X and PV formula. And in this case, you can see I have also added dates of the transactions where the money was put in or money was received. So again, investment was done on 26th August 2020, and then the next exactly after 1 year, 1 year, 1 year, 1 year, additional year, these transactions were done. So these are the dates I have entered. Yeah. So with that said, let me get started with the formula. So here you go. I'm going to start with equals to and then X NPV tab. So it starts my formula. First, I'm going to enter the rate, which is 10%, followed by, I'm going to say comma, and I'm going to select all of these ranges. Yeah. So you remember in the NP formula, I only selected the net inflow and I separately added the investment. In this case, that drawback of the NPV formula is corrected in your X NPV formula. So I'm just going to close it out, say close. Oh, so one more thing is, there is dates I need to add. So I'm going to select this series of dates as well. Now I'm going to close it out and say enter. And you see I get this calculated NPV value. And again, this number is very close to what we found over here, which is 9641. And this is also 9637. So it's very close. So this is how you utilize this X NPV formula. The additional information that you need is the dates on which the transactions were done, and then use the formula in a very similar way. And that's it for this concept. The next concept we're going to learn is one of very, very, very important, and I will say industry's favorite. The term is called as IRR, or internal rate of return. So in simple words, this is nothing but you must know whatever investment you have done with respect to your new business or the money you have put in or any project that your company has invested in. And once it is operational and when it is making profits, when it is making gains and so on, you must know what is the rate at which you are earning money in the reference to all your money invested. And that's the internal rate of return. Yeah, in simple terms, that's how you define it. And usually higher IRR is better. It can be. It can also be negative. Negative means your company or your project or your like a business is losing money. You have to do something to change that course of action. Yeah. So that's internal rate. So in simple words, it is nothing but the rate at which you are making money out of whatever investment you have done with respect to your project or your business. So this is a simple formula in Excel. You start with equals to IRR. Values, you select all the values, including the investment and net all the incoming. And in the guess, well, the scope of this class, we won't be using it. So just select all these, and Excel assumes that this is year investment in year 0, and bracket means negative, meaning the money has gone into your project or business. And all the other are looked at positive, meaning you're making money out of it. Yeah. So technically, Excel is thinking this is year 0, year 1, 2, 3, and 4, and it will do the calculations for you. And let's get started. So equals to IRR tab. It starts a formula, and all I'm going to do is select all of these values. And I will repeat again, Excel assumes this is all year in a sequential year, starting from year 0, that is your money you put in, followed by year 1, 2, 3, and 4 in this case. So I'm closing the bracket. Guess I'm ignoring it. So this is the rate of return I'm getting. So technically, if you invested 50,000 here and this is the cash flow that your business or project has come up with, you are earning at a rate of 18.79%, which is great IRR. So but technically, this is very close to 20%. So meaning within 5 years, I should be able to make up all the money I have invested. And beyond that, it's a pure profit I make from all the invested capital. Yeah. So this is what it means. So I'll just highlight this in yellow. And to just elaborate more, if you have to solve this problem manually, here is a formula you'll be using. IRR equals to a constant A plus NPV at A divided by NPV A minus NPV B. And again, these are the description for NPV A and B. So yeah, I mean, this will be very complex. So Excel does it for you. And in the longer run, as you proceed in your career, hopefully you can specialize in finance, or even if you don't, even if you are a part of any project engineering group or project analysis group or analyst group, you will be given a lots of data sets like these, and you'll be asked to analyze. And IRR is a term you'll be using, maybe not in the very first year of your career, second year of a career, maybe not 5 years, but on and off you'll be coming across if it's not your direct role. But this is a very important term to know, IRR, that is internal rate of return. Yeah, so this completes here how to use, what kind of data you will be needing to solve this problem that requires you to calculate your IRR using Excel. So far, we have learned about internal rate of return IRR formula in Excel. The next one is XIRR. So whatever limitations we had in IRR is corrected in XIRR formula. So in other words, in standard IRR formula, it is assumed by Excel that the cash flow happens at the very beginning of the year only. So yeah, so as per that, at the year 0th, before barely when the project started, the 4-year project started, this investment was done at the very first day of that year. And then at the very end of, after 365 days, this investment net flow happened. After 365 days happened, and so on for the remaining 4 years. In a real world, I would say in a normal business case, normally cases of companies and projects, that's not the case. These transactions can happen at any time, any point of the time. And that's where this XIRR formula comes into picture. Yeah, so that's the benefit of it. So here is the formula. You start with equals to XIRR, select all the values, hit comma, and select all the corresponding dates for it, and you will be getting the number. So in this case, since we are using, the end, like the whole entire year, we'll be getting more or less the same number. So let's try it out and see what we get. Equals to XIRR tab. Select all the date ranges, all the values. Select all the values here. Hit comma, then select all the corresponding date ranges. Close it out, press enter. I'm getting a same answer. So technically, this is a preferred formula to use in Excel. Just make sure you have all the dates of the transactions. Yeah. So for example, if I say for year 4, this transaction of 15,000 wasn't done on say 26th of August. It was done on 365. Yeah. Okay. So let me go with say 200. Yeah. So 365 is done at 200. So correspondingly, there are less number of days that were added in this case. So that's why this number changed. So this is more accurate, and it takes into account any date changes whenever the transaction has happened. Yeah. So for now, I'll just say Control Z. Let's stick with the original number. But this is how you will be using the IRR and XIRR formulae in Excel. So yeah, in other words, simple words, you don't have to go through all these cumbersome manual processing, either using Excel or a pen and a paper and a calculator. And again, chances are that, as the number of data points increases, your workload increases and there could be potential errors. But in Excel, just by using one formula and making sure your structured data is in in a right format, right table, it is a simple formula like this that will solve your problem.